Welcome students to online classes of mathematics for class 9th. In this video we are going to study chapter number 10, which is circles of NCERT textbook. This one is session number 4 for this particular chapter. He will be looking at the exercise 10.4. Okay, so myself Deepak Gautam, teaching mathematics in Kendriya Vidyalaya Sangathan. So let's start with our today's class. The chapter number 10 circles is divided into total 8 subtopics, out of which we have already covered the first 5 subtopics in the previous sessions. Today we'll be starting with the subtopic number 6, which is the equal chords and their distance from the center. Okay, so let's start subtopic number 6, which is equal chords and their distance from the center. In this first we have the theorem, which is a theorem 10.6 of NCERT textbook. It says the statement of theorem is equal chords of a circle or of congruent circle. So by this we means if we have the equal chords, like we have this AB and BC here, which are in the same circle, okay, or we can have two equal chords, again this AB and CD, in two congruent circle. That means the radius of these two circle is equal. Okay, congruent circle means the circles having equal radius. Okay, so we can have both case, that means the two chord in the same circle, or we can have two congruent circle having equal chords. In both case, if chords are equal, then they will be equidistant from the center or centers. Okay, that's what this theorem says. It says equal chords of a circle or of congruent circle are equidistant. Equidistance means equal distance. Okay, so if you have any number of chords which are equal, so if the chords are equal, then their distance from the center, that is this OM and ON, will be equal. And similarly this OM and ON will be equal. Okay, so this theorem simply says if AB is equals to CD, then the distance of this chord, that is OM, will be equals to ON. Okay, that's what this theorem says. If you find that the two chords are equal, then their distance from the center will be equal. Okay, so we'll not be doing the proof of this theorem. Okay, so we'll just have to understand its statement. Okay, next is theorem 10.7. It says chords equidistant from the center of a circle are equal in length. Okay, so this is the converse of theorem 10.6. It's saying the chords equidistant from the center. So if you have two chords which are equidistant from the center of a circle, then they will be equal in length. Okay, that is if this distance OM and OL are equal, that is if OM is equals to ON, then these two chords, that is PQ and RS, will be equal. That is RS will be equals to PQ. Okay, so this is the theorem 10.7. so in 10.6 we have if chords are equal, these are the chords, then their distance from the center will be equal. While in 10.7, if their distance from the center is equal, then the length of chord is equal. Okay, so we have these two theorem. So whenever you find these two cases, if the chords are equal, then the distance from the center will be equal, or if the distance from the chords are equal, then the chord will be equal. Okay, so if one is given to us equal, then another quantity will be by default equal. Okay, if chords equal, then the distance will also be equal. Okay, so based on this we have exercise 10.4. now let's move to the exercise 10.4 now. Here the question number 1 is two circles of radii is the plural of radius. Okay, this is plural of radius. Okay, so two circles of radii 5 centimeter and 3 centimeter intersect at 2 points, and the distance between their center is 4 centimeter. So we are having two circle, which one with the 5 centimeter radius and other with the 3 centimeter radius. Okay, they are intersecting each other at 2 points. Okay, and the distance between their center is given as 4 centimeter. We have to find the length of the common chord. This is very important question. Okay, so let's first draw its diagram. So this is the diagram for this question. We have the two circle, one is with radius 5 centimeter and other one with the radius 3 centimeter. Okay, and we are given that the distance between their center, that is O and O dash, is 4 centimeter. Okay, this is the circle 1 and circle 2. So let's start by writing the given part. This is answer number 1. Given here is, we have two circles with center O and O dash. Okay, let's write. Given is two circles with centers O and O dash, okay, having radii 5 centimeter and 3 centimeter respectively, and they're intersecting each other at point A and B. Okay, intersecting each other at 2 points A and B. Okay, so we have two circles, that is with the center O and O dash, and having radii 5 centimeter and 3 centimeter respectively. That means the circle with center O having radius 5 centimeter and circle with center O dash is having a radius 3 centimeter. Okay, and they are intersecting each other at point A and B as given in the figure. So what we have to prove here is, or we have to find here is, the length of the common chord. Okay, we have to find here is length of common chord, which is AB. We have to find length of common chord AB. Okay, as they are intersecting at 2 point A and B, that means AB is their common chord. So let's start its solution. So what we have here is, from the figure, let's write, we have this OA is equals to 5 centimeter. Okay, then we have O dash A is equals to 3 centimeter, and O and O dash, that is the distance between the circle, is 4 centimeter. Okay, so these are the things given to us. We can see from here that in triangle A, O and O dash, in this triangle, okay, we have that this OA square is equals to OA dash square plus O and O dash square. Okay, that is OA is 5 centimeter, OA dash is 3 centimeter, and O and O dash is 4 centimeter. So the 5 square is 25, 3 square is 9, and 4 square is 16. That means this 9 plus 16 is 25. So that means these values are satisfying the Pythagoras theorem. Okay, so we can say here, by Pythagoras theorem, by Pythagoras theorem, okay, as if this is satisfying the Pythagoras theorem, where the square of hypotenuse is equals to the sum of the square of base and the perpendicular. So we can say that AB is O, see A, O and O dash is a right angle triangle. Okay, so we can say by Pythagoras theorem, A, O and O dash is a right angled triangle, right angle at okay, since this 5 is the longest side, so the opposite angle, that is this angle, will be 90 degree. That means angle AO dash and A will be 90 degree. That means this is right angle at O dash. Okay, this implies that this is the perpendicular, this O and O dash is perpendicular on AB. Okay, let's create some space. This implies that hence O dash is perpendicular on AB, therefore this O dash is dividing the AB into two equal parts, that is A O dash is equals to B O dash. We know the perpendicular from the center bisect the chord. Okay, reason for this one is perpendicular from the center bisects the chord. Okay, therefore these two will be equal, and we are given that the AO is 3 centimeter. That means BO dash will also be 3 centimeter. Okay, and this implies that therefore, or you can say hence length of AB will be equals to twice of AO dash. Okay, since this O dash is bisecting the chord, that means it's dividing into two equal parts, so this AB will be twice of AO dash, so that means 2, and AO we already got here, which is 3 centimeter. Okay, so let's write it 3 centimeter. This implies that AB is equals to 6 centimeter. So that's the answer for the question number 1. We have to find the length of this common chord, that is AB, and that turned out to be 6 centimeter. Okay, so that's the answer of the question number 1. Now moving to the next question. Question number 2 is, if two equal chords of a circle, so we have two equal chords in a circle intersect within the circle. So we have two equal chords in the circle, they are intersecting within the circle. What we have to prove here is that the segment of one chord are equal to the corresponding segments of the other chord. That means we have a circle in which two chords are intersecting each other within the circle. Okay, so let's first draw its figure. So that's the figure of this question. What we have here is, we have a circle with center O, and we have two chords AB and CD. They are intersecting at point E, which is within the circle. Okay, and we have to prove that the corresponding segment are equal, that is this AE is equals to CE and this BE is equals to DE. Okay, so let's start the answer number 2. First we will write the given part. Given here is a circle with center O. Okay, given is a circle with center O in which we have two equal chords which are AB and CD. Okay, in which two equal chords which are AB and CD intersecting within the circle at point E. Okay, so we have a circle with center O in which two equal chords AB and CD are intersecting within the circle at point E. What we have to prove here is, we have to prove that their corresponding segments are equal. That means we have to prove that AE is equals to CE and BE is equals to DE. This is what we have to prove. These corresponding segments are equal. Okay, so let's start this proof. So before starting the proof, we have to do some construction here. So let's first write the construction. So construction, what we have done here is, we have drawn OM perpendicular on AB. Okay, so let's construction is draw OM perpendicular on AB and ON perpendicular on CD, and we are also join OE. So this is the construction we have done in this question. We have drawn this perpendicular OM and ON on AB and CD respectively, and we have joined this OE. Okay, now let's start this proof. Proof here is, what we are going to do is, first we are going to prove that these two triangles are congruent. Okay, with that we'll get this corresponding part ME and NE will be equal. Okay, so let's start in this triangle OME and ONE. Okay, so let's write in right triangles OME and triangle ONE. What we have here is that in these two triangles, first we have right angle, that is angle OME is equals to angle ONE. Okay, each is of 90 degrees, so we have got right angle now. Okay, then we have hypotenuse, that is OE is equals to OE, that means this is common, and the other side, that is OM and ON will be equal. OM is equals to ON. The reason for this one is these AB and CD are the two equal chord, therefore this distance from the center will be equal. This is the by the theorem. This is by the theorem 10.7. You have to write the statement of the theorem here, that is the chords equidistant from the center are equal in length. Okay, or if the length of the chords are equal, then they are equidistant from the center. So what we got is, we got right angle, we got hypotenuse and one side. Therefore triangle OME is congruent to triangle ONE by RHS congruence rule. This implies that these two part ME and NE are equal. ME is equals to NE. This is by CT. Okay, so from here what we got is that these two parts are equal. Okay, now what we're going to do is, now O is the center of circle and OM is perpendicular to AB. That means this point M is bisecting the chord AB, which gives us that AM is equals to half of AB. Okay, so let's name this as equation 1 and this one as equation 2. Okay, similarly NC, this is for the other chord, will be equals to half of this other chord CD. Let's name it equation number 3. And we are given in the question that the two chords are equal. Okay, we have two equal chord, so since that means this AB and CD are equal, this implies that from equation 2 and equation 3 we get that AM is equals to NC. AM is equals to NC. Okay, let's name it equation number 4. Also this will give us that MB is equals to ND. Let's name it equation number 5. Okay, since these two are the perpendicular from the center, so they will bisect the chord, so we got the corresponding parts of the chord will be equal. Now simply what we're going to do is we will add equation 1 to equation 4 and we'll subtract the equation number from equation 5. We will get the corresponding part of the chords, that is on adding equation 1 and equation 4 we get what we get is in equation 1 we have this am added to equation 1 we have me. Okay, on the other side we have this nc and we are adding this ne. Okay, this will gives, this implies is that ae is equals to ce. Okay, that means these corresponding parts we got. First part, that ae is equals to ce, and on subtracting equation 1 from equation 5 we get, okay, so first we'll write the quantities of equation 5, that is mb minus we have me, on the other side we have nd minus ne. Okay, after doing the subtraction we get the other second required result, that is this implies be is equals to de. Okay, this is b. So we got both the required result, that bg is equals to de and this ae is equals to ce, and this is what we were asked to prove here, that the corresponding parts of these chords are equal. Okay, so that's the solution of question number 2. Now moving to the next question, question number 3. Question number 3 is, if two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection of the center makes equal angle with the chord. So now what we have is, again we are given two equal chords, okay, and they are intersecting within the circle. We have to prove that the line joining the point of intersection of the center makes equal angle with the chord. Okay, so let's draw its figure first. So what we have here is, we have two equal chords AB and CD, and they are intersecting within a circle at point E. Okay, we have to prove that the line joining the point of intersection to the center, that is this OE, is making equal angle with the chord, that is these two angles. We have to prove them equal. Okay, we're gonna simply prove that these two triangles are congruent, and by simplicity these two angles will be equal. Okay, so let's start its answer number 3. First let's write the given part. Given is a circle with center O having two equal chords AB and CD. Okay, a circle with center O having two equal chords AB and CD intersecting within the circle at point E. Okay, so what we have to prove here is, to prove that the angle OEM is equals to angle OEN, that is these two angles we have to prove equal. Okay, so let's start by doing construction. Construction again same, draw OM perpendicular on AB and ON perpendicular on CD, and joined OE. Okay, so again we are going to prove that these two triangles are congruent by RHS congruence rule. Okay, so let's do this. Proof. We have in triangle OME and triangle ONE, we have what we have here is that angle OME is equals to angle ONE, each is of 90 degree. Okay, and since this chord AB and CD are equal, so the distance from the center, that is OM and ON will be equal. Okay, so first we are going to write OE is equals to OE, this is common, and OM is equals to ON. Okay, since AB is equals to CD. Okay, since AB and CD are two equal chords, therefore their center distance from the center will be equal. So we'll write therefore triangle OME is congruent to triangle ONE. This implies angle OEM is equals to angle OEN. This is by RHS congruence rule, and this is by CPCT. Okay, that is corresponding parts of congruent triangle are equal, and this is what we were asked to prove here, that these two angles are equal, and we have proved that these two angles are equal by CPCT. Okay, so that's the solution of question number 3. Now moving to the next question, which is question number 4. Question number 4 is, if a line segment intersect two concentric circle means two circles having the same center. Okay, so if a line intersect two concentric circle with center O, okay, so as we know, the concentric circle means two circles having same center. Okay, so their common center is O, and that line is intersecting the circles at point A, B, C and D. We have to prove that AB is equals to CD. Like you can see in the figure, we have two circles, one is a smaller circle and other is the larger circle. Okay, we can call them inner and the outer circle. Okay, this one is the inner circle and this one is the outer circle. Okay, so we have a line, let's name this line as L. So this line L is intersecting the two concentric circle at the 4 points, that is A, B, C and D, and we have to prove that these part AB and CD are equal. Okay, so let's start this answer. We have the answer number 4. First let's write the given part. Given here is line L intersecting two concentric circle with center O at A, B, C and D. Okay, what we have to prove here is that AB is equals to CD. Okay, let's do a construction first. So construction that we are going to is, we will draw a perpendicular from the center to this line. Okay, let's draw this here. Like this. Okay, let's name it this point as M. Okay, so construction is, Draw OM perpendicular on the line L. Okay, let's start this proof. Proof is we have this OM perpendicular on the line, or you can say chord CD. Okay, since OM is perpendicular on AD, therefore we have this AM is equals to MD. Let's name it equation number 1. Region for this one is perpendicular from the center, bisects the chord. Okay, this OM is perpendicular on the center, so it is bisecting the chord AD. Okay, also since OM is perpendicular on this for this inner circle BC. Okay, now the chord is BC, therefore BM will be equals to MC. Let's name it equation number 2. Region for this one is again the same, that is perpendicular from the center, bisect the chords. Okay, so you will write that again here. So from the two equation, what we got is that AM is equals to MD and BM is equals to MC. Okay, so let's subtract the equation number 2 from equation number 1. Okay, on subtracting, equation 2 from equation 1, we get what we get is we have AM minus BM, on the other side we have MD minus MC. This AM minus BM will give us AB, and this MD minus MC will give us CD. Okay, and this is what we were asked to prove, that prove AB is equals to CD. Okay, that's what we have proved here. So that's the solution of the question number 4. Now let's move to the question number 5 now. Question number 5 is 3 girls, Reshma, Salma, Mandeep, are playing a game by standing on the circle of radius 5 cm drawn in a park. So there are 3 girls, namely Reshma, Salma and Mandeep. They are playing a game by standing on a circle whose radius is given as 5 meter, okay, drawn in a park. Reshma throws a ball to the Salma. Okay, Reshma ने एक ball throw किया सलमा को, and the Salma to Mandeep, then Salma to Mandeep, then again Mandeep to Reshma. So Mandeep again throw that ball to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meter each, so we are given the distance between Reshma and Salma and Mandeep, which is 6 meter each. Okay, so we are given two measurement here. One is the radius of the circle and the distance between Reshma and Salma and Mandeep. What is the distance between the other two girls, that is Reshma and Mandeep? This is what we have to calculate. Okay, so let's first draw its diagram. So that's the figure for this question in which we have 3 girls, Reshma, Salma and Mandeep, standing at point B, A and C, and the radius of the park is given as 5 meter, while the distance between Reshma and Salma and Mandeep is given as 6 meter each. Okay, so let's start a solution, that is answer number 5. So what we have, let 3 girls, Reshma, Salma and Mandeep, are standing at point B, A and C. Okay, let 3 girls, Reshma, Salma and Mandeep, are standing at points B, A and C respectively. Okay, and what we have done here is we have joined AO which will give us that this AO is passing through the midpoint of BC. That means M is the midpoint of BC. Okay, so we'll write, we have joined AO. This gives AO bisecting BC, that is M is the midpoint of BC. Okay, since M is the midpoint of BC, that means, and this M is joined to O, which this gives that this OM is perpendicular on BC. Okay, therefore OM is perpendicular on BC. Okay, now using that we can have this angle also as 90 degree. Okay, now in the two triangle, that is in triangle, we have two right angle here, that is first in AMB and second in OMB. So we'll take this triangle AMB, this one, and OMB, will apply the respective Pythagoras theorem in that. Okay, with that we'll try to find the value of BM. Okay, so let's write, in right triangle, first we'll take the triangle ABM. We have, okay, we know by the Pythagoras theorem, in right triangle the square of hypotenuse is equals to the sum of the square of base and the hypotenuse, sorry, base and the perpendicular. That is AB square, which is the hypotenuse in this case, this AB, will be equals to the sum of the AM square plus BM square. Okay, so from here we have AB is given to us, which is 6 meter, AM we don't know, and also BM we don't know, so we'll keep this as AM square plus BM square. We'll try to find the value of BM from here, that is BM square from here will be, this 6 will be 36 minus AM square. Let's name it equation number 1. Okay, and we're going to apply the Pythagoras theorem now in the triangle OBM. Okay, now in right triangle OBM, we have, what we have is that, again applying the Pythagoras theorem, here the hypotenuse is BO, or you can say OB. So this OB square will be equals to the sum of the base and the perpendicular, that is OM square plus BM square. Okay, OB is given to us, which is 5. OM, we can write this OM as, this OM as AO minus AM. So this we have this complete OM. Okay, we can find this OM by subtracting AM from AO. So at the place of OM we can write OA, which is the total length, and we are subtracting the part AM from it. Okay, when we do this, we're again gonna get this OM. Okay, and we have this BM square. Okay, so let's find the BM from here. BM square from here will be, this 5 square will be 25. Okay, then this term will be shifted to that side, that is OA minus AM square. Okay, and we are given this OA, since this is also the radius of the circle, so this will also be of 5 meter. Okay, so we have 25 minus this 5 minus AM whole square. Okay, let's name it equation number 2 now. So from both the equation 1 and 2, what we have is, we have the value of BM square, and they have to be equal. Okay, so we'll write, on comparing equation 1 and 2, we get, from equation 1 and equation 2, we get, as both are giving the value of BM square, so they have to be equal. So we have 36 minus am square will be equal to 25 minus 5 minus am whole square. Okay, so what we are going to do now is we'll shift this 25 to on the other side and am on the other side, and we'll expand the a plus b whole square identity here. So we have 36, this 25 will shift to on this side will be minus 25, and this minus am square will shift to the other side will be plus am square. Okay, then we have minus, let's expand the a minus b whole square here. So we have a square, which is 25, then we have plus b square, that is am square, then we have 2ab, that is 2 into 5 is 10 am. Okay, so we have 36 minus 25 is 11. On the other side we have this am square. Okay, let's open the bracket, so all the signs will be reversed, that is minus 25 plus minus am square and minus 10 am. Okay, so these two will be cancelled out. So what we left with, this minus 25 again shifted to the other side will be 11 plus 25. Okay, so we get what we left with here with only this. Okay, this will be minus here, and when we open the sign this will be plus, because we have the minus sign here, 2a minus b whole square. So this is a square b square minus 2ab. So okay, after opening the bracket this will be changed to plus. So we have 10 am, or am 10 am will be equals to this 25 plus 11 will be 36, or am will be equals to 36 divided by 10 equals to 3.6 meter. Okay, so what we got is, we got the value of this line segment am, this one. Now using this am value here we can find the value of bm. Okay, now let's write using value of am in equation 1, we get equation 1 is bm square equals to 36 minus am square. Okay, so am here is 3.6 square. Okay, so bm square is equal to 36 minus 3.6 square will give us 12.96. okay, or bm 23.04, or from bm from here will be under root 23.04. when you find the root of this 23.04 you will get the result as 4.8 meter. Okay, that means bm is equals to 4.8 meter. bm is this part, and we have to find the whole length bc. Okay, and we have hence bc is equals to twice of bm, that is 2 into 4.8 meter. This will give us 9.6 meter as the length of the bc. That is hence the distance between Reshma and Mandeep is between Reshma and Mandeep is 9.6 meter. Okay, that's the answer of the question number 5. Okay, now moving to the next and the last question of this exercise, we have a circular park of radius 20 meter is situated in a colony. 3 boys, Ankur, Sayyad and David, are sitting at equal distance on its boundary, each having a toy telephone in his hand to talk to each other. Find the length of the string of the each phone. Okay, so we have a circular park whose radius is given as 20 meter, and we have 3 boys now, Ankur, Sayyad and David, which are sitting at equal distance. Okay, so let's first draw its figure. So that's the figure for this question. We have three boys, Ankur, Sayyed and David, which are sitting at the point A, B and C of this circular park. Okay, so let's write his answer. We have answer number 6. So what we have here is a circular park with radius of 20 meter. Okay, given is we have a circular park of radius 20 meter in which three boys, Ankur, Sayyed and David, are sitting at points, let A, B and C. Okay, so we have three boys, Ankur, Sayyed and David, situated at point A, B and C. Okay, since it is given that the distance between each them is equal, okay, they are situated at a equal distance, so this will give that is let ABC is an equilateral triangle with side 2x. Okay, since they are situated at the equal distance, that means the length of these three sides are equal, and we have taken that as 2x. Okay, so now what we're going to do is we have joined this O to a point M. Okay, that means this OM is perpendicular on BC, and we know that perpendicular from the center will bisect the chord. Okay, so we'll have clearly BM will be equals to half of BC. Okay, because we have joined this OM, and therefore M will be the perpendicular from the center to a chord BC, and it will bisect the chord. That is BM will be half of BC. That is BC we have taken as 2x, that is the each side of the quadrilateral we have taken them as 2x. Okay, so BM will be x. That's what I have written here. Okay, so now in right triangle, so first we'll take the triangle ABM, and we'll apply the Pythagoras theorem in this. That means in right triangle we have this square of hypotenuse, that is AB square will be equals to the sum of the base and perpendicular, that is BM square plus AM square. Okay, so from here AM square will be AB square minus BM square. Okay, so from here AM square will be AB we have taken as, that is the side of each side of this equilateral triangle as 2x, so the AB will be 2x. Then we have BM we have taken as x, which is the half of BC, so this is x. So this 4x square will give us 2x square will give us 4x square, and this x whole square will be x square. This will result as AM square is equals to 3x square. Okay, or AM will be equals to under root 3x square or root 3x. So we got the value of the side AM. This AM is root 3x. Okay, we have now we can write this OM can be written as the AM minus OA. Okay, this side OM can be calculated by subtracting this AO from AM. Okay, that means we have this OM equals to AM. This AM we have calculated here, which is root 3x, and AO is the radius of this circle, that is 20. So OM we got as root 3x minus 20 meter. Okay, Now we again apply the Pythagoras theorem in this smaller triangle. Now this OBM, okay. Now in right triangle OBM, okay, using Pythagoras theorem, what we get is that this OB square will be equals to the BM square plus OM square, okay. So let's insert the values. OB is the radius of the circle, which is 20 meter. We have BM we have taken as x, and OM we have calculated in the above equation, that is root 3 x minus 20 whole square, okay. So this 20 square will be 400 equals to x whole square will be x square. Then we have plus, let's expand the identity, a square plus b square minus 2ab in this one. So we have a square, that is 3x square, then we have plus b square, which is 400 minus 2ab will give us 40 root 3 x, okay. Since we have plus outside, so all the sign will remain as it is once you open the bracket. So this will be 3x square plus 400 minus 40 root 3x, okay. So this 400 and 400 will be cancelled out, because when you shift this to other side it will be minus 400, so that will result as 0, okay. So what we got is this 400 minus 400. On the other side we have this 4x square minus 40 root 3x, okay. This will result as 0. Taking 4x common, what we get is x minus 10 root 3, okay. So that means after multiplying this 4x and x minus 10 root 3, we are getting the result as 0. So either this term is equal to 0 or this term is equal to 0, okay. So if we put this 4x equals to 0, this cannot be possible, because there should be some value of x, okay, and that will give the some value of the, so that means this equation is not satisfying. So what we have is x minus 10 root 3 equals to 0, and this implies that x equals to 10 root 3 meter. That is the value of this x is equals to 10 root 3, okay. And we have to find the side of this, the phone string that they are using. So we can write, hence you can calculate any of the side, okay. Hence BC, which is the twice of BM, will be, BM is the given by the x, that is an x we have calculated as 10 root 3 meter. So this will result as 20 root 3 meter. That is the value of the BC, or the string of the telephone which these children are using, okay. So that's the answer of the question number 6 of this exercise. With this we have completed all the six questions of this exercise. Please solve this question multiple times so that you understand it better, okay. So that's all for now. Thanks for joining in, everyone. Thank you.